The technological process in the harvester starts with the header. It consists of a reel, a header auger, and a cutter bar. Along the movement of the harvester, the reel feeds the crops to the cutter bar. The harvested crop is cut, then the reel moves the cut crops to the header auger. The rotating auger moves the cut mass to the center of the header. In the center of the header, there is a finger mechanism that moves the mass to the feeder house. The feeder house has 4 beaters. Torum harvesters 750, 780 have got a beater feeder house. The mass from the header is fed to the finger beater. Then it's transported to the next beater. The next beater accelerates the mass movement. All 4 beaters rotate with different speeds, from the slowest to the fastest. With the help of beaters, the mass is transported into the intake cone. The rotor has blades that capture the mass, and then feed this mass into the thrashing and separating unit. Here you see a rotating concave. The deck rotates counterclockwise. The rotor rotates clockwise. The concave has got 4 sections. The first 2 are the thrashing sections, where the mass is thrashed with the help of rotor and concave rasps. The other 2 are the separation sections. Here the mass is spilled onto the return board. The main mass is spilled in the first 2 thrashing sections, and then falls onto the shaker pan. Everything that falls on the shaker pan, due to in and out movement, is transported to the pre-sieve. On the pre-sieve, the separation process occurs. Clean grain is spilled on the lower sieve. In this area, a flow of air starts cleaning the mass. From the lower sieve, the grain is spilled onto the chute board. Down the chute board, it falls onto the grain auger. The grain auger transports it to the grain elevator. With the help of a grain elevator, the mass is delivered to the grain tank. The mass that didn't spill on the pre-sieve is moved to the upper sieve. From the upper sieve, the clean grain falls on the lower sieve. Some unthreshed wheathead fragment may fall on it as well. The clean grain is spilled and transported to the grain auger. If the wheathead fragment gets in there, it can't go through the lower sieve. It is moved to the end of the sieve, and then, down the chute board, it falls onto the tailings auger. This auger moves the mass to the rethrasher, threshed again there, then moved to the return board. Then down this board, it is spilled to the cleaning area. And then the cleaning process is repeated. As to the separation section, the grain that hasn't been spilled before in the previous sections is spilled here in these 2 sections. It is spilled on the return board and returned to the cleaning unit. At the end of the rotor, we have a straw output. The straw is moved down, and with the help of a straw beater, is forced out of the combine. Small particles and chaff, which are blown by the fan, are also moved here. Eventually, all this mass flow is spread on the field, if the chopper is in the windrower mode. If it's in the chopping mode, the mass is fed to the chopping drum, then it's chopped and spread across the field. The reaping part of the harvester. Adapters that can be installed on the harvester. The first one is the header RSM 081.27 or power stream. It may have a ripping width of 7 to 9 meters for Torum harvesters. It is used for direct harvesting of grain crops and leguminous crops. Next comes the pickup platform RSM 081.08. It is used for split harvesting. When the crop is harvested and left in swaths, using the platform, we pick the harvested crop from the swaths and feed it to the combine. The capture width is 3 or 4 meters. Argos, the device for harvesting corn, the device for harvesting sunflower, the device for harvesting rape. We use this device as an extension to an ordinary grain header RSM 081.27, and so after installing this device, we can harvest rape. Transport trolley is used to transport the header weighing up to 3 tons. The other type of trolley, TT4000, is used to transport heavier headers weighing up to 4 tons. Using this trolley, you can transport headers for harvesting rape and corn. RSM header 081.27. The header consists of a reel, a cutter bar, and a header auger. All of them are fixed on the housing. The reel moves the stems of the crop to the cutter bar and then feeds them to the header auger. By rotating, it feeds the mass to the cutter bar. It is activated automatically together with a feeder house drive. Any deformation of the reel tube is strictly prohibited. When transporting, make sure that the reel tube is not bent. If it's deformed in the process of shipping, the shipping company bears responsibility for it. If the deformation is not detected before harvesting, during the harvesting, a crack may appear in the place where it's bent. If this damage occurs, you will have to strengthen and weld it, but of course, it will not be a warranty case anymore. The reel drive is hydraulic. On the right, there is a hydro motor. Here you see it fixed on the platform. A chain gear connects it to the reel. Here we see the 4 bolts that fix the hydro motor. With the help of a hydro motor fitting, we can change the chain tension. To adjust the tension of the chain, release the bolts and move the hydro motor in the holes. It is prohibited to use the given rod to adjust the chain tension. The given rod is used to align the sprockets. If we start moving it, we will change the length set at the factory. This may lead to disaligning of the sprockets and premature wear of the chain and the sprockets. The service vehicle must have the following tool. On the left, you see the belt tension checking tool, and on the right, the chain tension checking tool. There is also a laser tool for checking alignment of pulleys and sprockets. Here, you can get the information about the allowed deviation. The pulley's grooves alignment must be 2 mm per 1 meter of the distance between axes. So here's the pulley, and here's the pulley. If the distance is 1 meter from the center, the axial deviation may be not more than 2 mm. If the distance from the center is more than 1 meter, Per each 100 mm, the deviation of not more than 0.2 mm is allowed. The similar situation is with sprockets. To use this device, place the magnet parts on the transmitter and receiver. Then install them on the pulleys as shown on the figure. Then switch on the laser. And then on the scale, you will see a line. The closer the line is to the 0 point, the smaller the disalignment is. The line can be located on the left or on the right of the 0 point. Here we take into consideration the given standard. The maximum disalignment, 2 mm per each meter. When completing the header assembly, you will need to install the reel arms, which are located in the header itself. To do this, loosen the reel arms. By loosening the bolts on the reel arms. After loosening the reel arms, pull the cord and place the reel arms on the same plane. After this, we can install the tying arms. The important thing here is to align the tying arms. None of the arms may be bent. All of them must be located in the same plane. If we see the disalignment of one of the arms, as shown in the picture, here you see that the tying arm is disaligned. During harvesting, the disaligned arm will be eventually bent or broken. Next goes the reel bar's angle adjustment, on the left and on the right, on the left and on the right, of 7 and 9 meter headers. For this procedure, 2 levers are used on the left and on the right of the headers. The most important thing is to install the levers in identical holes, otherwise it will lead to the reel bar's disalignment. The adjustment depends on the height of the standing crop. The minimum distance between the reel bar fingers and the cutter bar is 25 mm. If the distance is less than 25 mm, or much more than that, the hydro cylinders have special adjustment spots on the left and on the right. To adjust this position, loosen the lock nuts, and then, rotating this part, you will screw it in or out to lift or lower the reel. The similar adjustment can be performed on the left hydro cylinder. Use this adjustment to set the above-mentioned parameter. The next adjustment is the adjustment of reel position. We can move it to the left or to the right, but only when it's necessary. For example, if the reel touches the header housing, in this case, such adjustment is required. To perform this adjustment, remove the housing, lift the reel, move the necessary amount of washers to the side you need, then lower it, and perform an identical procedure on the right side, placing the identical amount of washers. Beater feeder house consists of 4 beaters. The feeder house drive is on the right. The given pulley drives the upper beater. Then the chain drive on the left moves the intermediate beater. On the upper beater shaft, there is a small pulley. The belt drive connects the small pulley with the lower shaft. This shaft and the intake beater are connected with a chain drive. The intake beater is connected with an intake finger beater by a chain drive as well. On the left and on the right of the pulley, there are safety clutches. In the given figure, you can see the correct names of all the beaters located in the feeder house. This clutch is installed on the right pulley. Its nominal torque is 25 newtons per meter. The sprocket also has a safety clutch, 300 newtons per meter plus minus 30 newtons per meter. Under the feeder house, a stone trap is installed. This lever opens the stone trap. Open the stone trap and empty it because there can be stones in it. The stone trap cleaning procedure is recommended when working on the fields with stony soil. Clean the stone trap at least once in 24 hours. Usually it's done before the new harvesting day. To open the stone trap, just push the lever. The shield will open and the stones will fall out of it. To close the stone trap, apply some force and move the lever up. Feeder house reverse. This function is controlled from the cab on the control panel. When you press the button, the hydro motor, which is located on the right under the feeder house, is geared with this shaft. Due to the cylinder movement, the hydro motor starts moving out. And when the sprockets are geared, the motor starts rotating. This way, it moves the header and the feeder house rotate in reverse. Also, when this function is switched on, the reel is lifted automatically. Reverse adjustment. This is the position of the cylinder. At the end of the cylinder, there are adjustment nuts. If you need to replace the cylinder or dismount and mount it again on the feeder house, you have to adjust the given position so that if the cylinder pin is moved out completely, the sprockets must be completely engaged and the hydro motor must rotate. If it is not properly adjusted, the pin moves out completely, but the sprockets are not engaged. Or another situation, the pin does not move out completely, the sprockets are engaged, but the reverse is not working. The position of the elements that we need is the following. The pin is in the end position and sprockets are engaged. The finger beater adjustment on the left. This is the support, changing the intake finger beater support position. As you see, there are 3 holes. The upper ones are not used in harvesters for Russia. Normally, we use the middle and the lower one. The default position is the middle one. Thus, it's the maximum possible position of the beater. If you have to lower the beater, which is necessary in case you're working with a small amount of mass. In this case, the beater does not grab the mass and it will be necessary to lower it. To do this, change the position of the bolts on the left of the feeder house. You have to screw them out and screw them into the lower holes. On the right, we have a tensor. With the help of the tensor, we adjust the position of the beater. While doing this, measure the distance between the beater and the feeder house under tray on the left and on the right. Please note that before adjusting, you have to loosen the bolts, this bolt, and this one, then the third and the fourth, but they are not visible in the picture. It's not necessary to screw them out. You simply have to loosen them on both sides. If we come back to the previous picture, we will see these bolts. The first, the second one, and we don't see the third and the fourth. Here, we see extensional holes. By loosening the bolts and moving the shaft, we'll be moving up and down these holes. After moving the beater up or down, you have to tighten these bolts. The feeder house can be dismounted in the field. The header can be left on the ground when it's detached, but before that, you have to put special supports under it. That if the soil is too soft, the header might sink in because of the heavy weight. In this case, you'll have to let the tires down a little bit so that you can approach the feeder house, mount it, and fix it. If you're doing it in a garage, use a special trolley. Dismount the intake feeder beater through the front part of the feeder house. Before doing that, detach the rods on the left and on the right. Also detach the hydro cylinders. Then incline the frame of the feeder house. To dismount the beater, first detach the chain drive of the beater. Then unscrew the bolts, not loosen them. 4 bolts on the left and 4 on the right. You see all the 4 bolts in this picture. After you remove the bolts completely, you can take out the beater and the shaft through these holes. The beater is taken out together with the shaft and the blades to make it easier to equip the combine for harvesting corn. It is necessary to remove the 4 bolts on each side. You have to do it because of the following reason. If you remove the side wall of the feeder house, you will see that each beater, including the feeder beater, has got such a cup. It is mounted inside the beater. So if we don't remove the bolts, they will be holding the cup, and we won't be able to remove the beater. That's why only after removing the bolts, you will be able to take out the cup and the beater. So when dismounting any of the beaters, you have to remove the bolts on the left and on the right. If you have to dismount the intake beater, not the finger beater, pull out the bearing. But before it, remove the chain drive and remove the sprocket. Pull out the bearing. Then you will see the hole, and inside it there is a shaft and terminals. To dismount the shaft, because if you don't remove the shaft, you won't be able to remove the beater. Loosen this terminal. You can do it either through this hole. If you don't have special tools to loosen the terminal, you can do it through the upper part of the feeder house. To do this, first you have to unscrew the hatch. Through this hatch, you will be able to reach the given place on the beater. As you see, this place is covered by the hatch. First unscrew the small hatch to reach the hole. This hatch prevents the mass from falling in there during harvesting. Unscrew the hatch, and through the hole under it, you will be able to reach the terminal and loosen it. The same procedure is for the intermediate beater. You also have to unscrew the small hatch to reach the terminals and loosen them. Here you also see the replaceable pads. You replace them as soon as they are worn. Before replacing them, we can rotate them by 180 degrees. Unscrew them, rotate them, and you will be able to use them for quite a while. After the complete wear of the other side, you have to replace them. You need these pads, not to replace the beater when the metal is worn. The removal of the upper beater is done only when the feeder house is dismounted completely. The three other beaters, the intermediate beater, the intake beater, the intake finger beater, are removed through the front part of the feeder house, which means you don't have to detach the feeder house. If you need to dismount the upper beater, the feeder house must be detached. Here you see the hole through which you remove the shaft. After you have removed the shaft, you will be able to dismount the beater. Thrashing and separating unit. The unit consists of a frame on which the intake cone is located. Inside the frame, there is a rotor. Outside the rotor, there is a concave frame. The concaves are installed on it. On the left, there is a concave drive. The drive rotates the concave. At the back, there is a rotor drive reduction gear. The rotor drive reduction gear has got two stages. It is produced by Walterscheid. It has two speeds. The first speed is used for harvesting the row crops. The second speed is used for harvesting green crops. The rotor is driven through the power reduction gear of the engine. It is also produced by Walterscheid. From the reduction gear, via the driveline, the rotor drive reduction gear is rotated. This is done via hydraulic coupling. The coupling is switched on when you press the button that activates the thresher. The friction couplings are located there. Due to oil pressure, these friction couplings are squeezed, and the torque from the reduction gear goes to the driveline, and the reduction gear starts rotating. On the reduction gear shaft, a pump of the hydrostatic transmission drive is attached. The pump of the rotor hydrostatic transmission drive and the rotor hydrostatic transmission motor are used to change the rotor RPM. If you remove the pump drive and lock the sprocket engaged with the hydro motor, the rotor will rotate, but only at one speed, at the speed selected before the start of the rotor. The rotor drive reduction gear looks like this in the section. This is where the driveline goes. On this side, the hydrostatic transmission pump is installed. When the driveline rotates, it rotates the shaft. Thus it rotates the pump. Only when the rotor is activated. The conic gear is rotating as well. It is marked by a red color. It is engaged with the given gear. It's marked in yellow color and located on the green shaft. The green shaft is engaged with two gears, orange and blue. Each of them are responsible for the gear ranges, the first and the second speed. On the opposite side, there is a range selection mechanism. When we select the ranges, we move this slide bar to the extreme right or extreme left. This way, the central gear is engaged. With the orange one, or the blue one. In any case, this mechanism must be located in one of the end positions. It is monitored by two sensors. If we don't have a signal from any of the ranges, the rotor will not start at all. The blue and orange gears freely rotate on the shaft, colored in red. While this gear is firmly engaged with the red shaft. That's why, when one of these shafts rotate, it changes the speed of the red shaft. In its turn, the red shaft is rigidly engaged with the crown. In the picture, the crown has blue color. The crown rotation speed will be stable and will depend on the selected range. Inside the crown, there are satellites. If you look from the top, the satellites are the three circles. The green gear in the center with outer teeth is called the sun gear. The sun gear does not depend on the red shaft. Here it rotates freely, so the rotation speed does not depend on the selected range. It is firmly connected with the yellow gear. The yellow gear is engaged with hydromotor. This gear is controlled with a hydrostatic transmission. If you change the rotation speed of this gear or the direction of the rotation, the satellite's rotation speed will be changed as well. The satellites are connected with the output gear, which is in turn connected with the rotor. This plate is put on the satellites, which have got small axes. The plate is put on these axes. Depending on the speed of the satellites, the speed of the plate will change. In its turn, the plate is engaged with the output gear. As a result, we change the rotation speed of this gear and the rotor. This is the way it happens. For example, you choose the second range, and then press the increase button. Then we press the button of rotor RPM increase. We start increasing the rotation speed of the sun gear. The sun gear rotates in the same direction as the crown. If the crown rotates clockwise, the sun gear will rotate in the same direction. We change its rotation speed by pressing plus or minus buttons. By pressing the plus button, we increase the rotation speed of the sun gear, and thus we increase the speed of the satellites. If you make the sun gear rotate in the opposite direction, and the crown never changes its rotation direction, it always moves clockwise. Using the hydrostatic transmission, we can make the sun gear rotate in the opposite direction. Then, we will be slowing down the rotation speed of the satellites, and with it, we'll be slowing down the rotation speed of the rotor. With the help of this planet gear, you change the rotor RPM in the selected range, the first or the second one. If you block the gear, the satellites will be rotating around it with one steady speed, depending on the speed of the crown. The faster the speed of the crown, the faster the satellites rotate, and so the rotor will rotate faster as well. When you have selected the second range, it becomes constant, and the gear does not change its diameter. So in this case, the crown speed will be constant. In the second range, it'll be 750 RPM. By changing the rotation speed and the direction of the sun gear, we can increase the rotation speed to 1000 RPM, or decrease it to approximately 600 RPM. Rotor drive reduction gear, waterside. It has two ranges, which are selected in the cab. the selector is hydraulic. On the display, you press the button of the necessary range. This procedure activates an electric magnet necessary for switching the chosen range. In this place, there are sensors that track the selected range. On the reduction gear, on the right, there is a pump of the rotor hydrostatic transmission. Above, there is a motor of the rotor hydrostatic transmission. Rotor drive reduction gear Bondioli. It doesn't have ranges selection. It works in one wide range from 250 to 1000 RPM. But it has the pump of the rotor hydrostatic transmission and the hydrostatic transmission motor. It also has an additional cylinder, which is responsible for the emergency rotor activation. This function is used when the rotor is clogged. The concave is activated with a belt drive. The pulley also has a safety clutch. On the other side of the frame, there is a reduction gear itself. It is also produced by Bondioli. For adjusting the tension of the chain, an automatic tensioner is used. And the constant rotation speed of the concave is 8 revolutions per minute. Please note that the concave rotation speed does not change. The input window is the place where the feeder house is fixed. Here's the input window, and this is the input cone. Here we see the rotor blades. Rotor support holder. Behind this hatch, there are 4 greasing points. This is what the rotor looks like. The rotor has got rusps. In the photo, you see their positions. The other holes which are not used are plugged with bolts. On no circumstances should you unscrew these bolts, because during the harvester operation, there will be access to these holes. The inside of the rotor will be easily accessed and may be filled with chaff or straw. And during the operation, this compressed mass can cause disbalance, and this rotor disbalance will be very difficult to remove. The front end of the rotor has got flightings. They are dismountable, so in case one of them breaks down, you can replace it. When one of the flightings breaks down, you have to change the pair, because each pair of new flightings has got its own weight. This is necessary to prevent the possible disbalance of the rotor. Behind the flightings, there are knives. Make sure that the knives are always sharp. In case they get blunt, you have to sharpen or replace them. You can access the knives on the left. When we open the shield, we dismantle the concave. Through the special window, you can access the knives and maintain them. The back end of the rotor. It has an adapter coupling. The reduction gear of the rotor drive is connected here. The balancing plates are located in this part as well. The concave's frame. As you see, the concaves are installed on it. The adjustable ones, there are 6 of them. They are placed in pairs. So there are 3 pairs of adjustable concaves. The non-adjustable concaves are also placed in pairs, and there are also 6 of them. The non-adjustable concaves are firmly fixed, with the 3 balls at the top and 3 bolts at the bottom when slot mortises break. Replace them if they are the smaller ones. The old ones are cut down, and the new ones are mounted. The old ones were 7 mm, the new ones are 9 mm thick. Make sure to measure the thrashing clearance and take a photo of it. During the harvester operation, make sure to use the following table of thrashing and separating settings. The thrashing clearance is adjusted through the hole after you remove the shield. To make it more comfortable to adjust, remove the belt drive of the concave. Thus you will be able to manually rotate the concave, because we have 3 points of thrashing clearance adjustment. Using this point as an example, let's see the way it is adjusted. On the first section we have a ruler. The ruler with letter Z shows the clearance between the rotor and concave rasps. Always use the given scale when you conduct the adjustment. Although we have the right scale as well, it's marked with letter S. It's a universal scale, it is used on different concaves. On the grain concaves, we use the left scale. How do you check the clearance? It is checked on the scale, vertical to the frame. You can put a square object at the angle of 90 degrees against this white frame. This procedure will help us to see what clearance we have between the rotor and the concave. If you have to change the clearance, loosen the lock nuts, this nut, then rotate the central part. By rotating it, we will either pull the mechanism apart or together. When we pull it together, the clearance becomes smaller. When you move it counterclockwise, the concaves move away from the rotor, and the clearance gets bigger. After adjusting the clearance, don't forget to tighten the nuts. Repeat the same procedure twice, for 2 pairs of decks. To do this, we move the concave rotation behind the reduction gear. Before doing this, take off the belt, rotate it to the next pair, adjust it, rotate to the next one, and adjust it. The clearance must be similar in all the 3 points. The concave stopping mechanism is on the right. It has a form of a ratchet. On the body of the concave's frames, there are cams located at equal distances. They're placed around the circumference. And here is the lever. When the concave is rotated, it touches the cam and slides off it. The similar process occurs around all the circumference. So during the rotation of the concave, we will hear peculiar clicks. In case the drive belt or the chain is torn, the concave stops. The rotor will still be rotating, and when the mass is input, it will be trying to rotate the concave in the same direction, clockwise. So one of these cams will be stuck on the lever and won't allow the concave to rotate together with the rotor. Thus the concave will be stopped. The rotor will still be rotating, the thrashing will still continue, but the effectiveness of the thrashing will be low, because it won't provide the 360 degrees separation. For this reason, the upper part will be clogged with chaff and straw. Technically, it's possible to continue working that way, but only until you quickly fix the problem. For example, change the belt or the chain. But if you actually decide to work with a blocked concave, you have to regularly open the shield and clean the chaff and straw from the top. Here, we also have a concave blocking sensor. It is used to detect the stopping of the concave and inform the driver about it. As soon as the concave stops and starts pressing on this lever, the sensor goes off, and the driver is notified that the concave is blocked. When the driver gets the signal, he has to inspect the concave and detect the possible problem. For the sensor to work properly and the driver to be notified correctly, loosen the sensor holder and move it all the way in. When it touches the magnet, move it away, move it 2-3 millimeters away, and fix it. In this case, when the lever presses the concave, the lever starts moving away to a distance necessary for the sensor to detect the stopping and notify the driver. The alignment of the rotor and the concave is done at the plant, and you don't have to do this procedure regularly. But if the procedure is really necessary, for example, in the case when you have changed the concave frame, this normally happens after a major damage, when you have to take it out and replace the inner parts. During this process, you will have to loosen the lower rolls, and after that, realignment may be necessary. The point of this adjustment is to align the rotor rotation center with concave frame rotation center. This is the sectional view from the back. This alignment is necessary for the thrashing clearance to be identical in all points. For example, you may have a situation when here you have 10 millimeters and here you have 30. Or here the clearance may be 15 and here 5. Or it may even touch the concave rasps. That's why this adjustment is really necessary. The checking procedure goes as follows. You measure the distance cornerways here and here. You check how big the difference is in these 2 points. The distance must not be more than 2 millimeters. If the distance is bigger, you have to start the alignment. To do this, loosen the 4 rollers, 2 at the top and 2 at the side. Loosen the nuts that fix them and move them away. The lower rollers are used for adjustment. They are eccentrical. By rotating these eccentrical rollers, we change the concave rotation center, and thus we may achieve the desired result. After the adjustment, tighten the lock nuts to fix the rollers. We place the rest of the 4 rollers so that the clearance is not more than 2 millimeters. So the clearance between the rollers and the concave frame must not exceed 2 millimeters. Here are the adjustment points on the other side of the panel, and here there are 2 nuts. One is for tightening, the other one is a lock nut. The lower rollers have the similar construction, but if you look more attentively, you can see the axis for the square wrench. It is done to make it possible to crank the eccentric. After you have adjusted it, tighten and fix the nuts. This is the platform which is located under the upper rollers. It has special notches to fix the rollers more firmly in their place. There are 4 back rollers. The upper 2 are placed at the distance of 2 millimeters. The lower ones are not adjustable and they are not eccentric. The axis here is rigid and the rollers are fixed in it. On the other side we see that the upper ones are adjustable, but the lower ones have no adjustment nuts. On the concaves, there are rails. The positions of rails can be changed. In the picture you see that there are holes. So a rail can change its inclination angle. By changing the angle, we change the mass output speed. The bigger the inclination level is, the faster the mass output speed is. If the inclination level is around 90 degrees, the mass is hindered. It takes more time for the mass to go through the thrashing and separation unit. This setting, this adjustment is necessary for different types of yield. In case of high yield, this adjustment might not be necessary at all. In case of low yield harvesting, it might be necessary to hold the mass in this thrashing separation unit to fill it with more mass. If the mass goes through the thrashing separation unit too fast, if the yield is really low. In the case of low yield, the mass goes through the thrashing separation unit too fast. It is thrashed, but it's not separated. When it goes out unseparated, it leads to a big amount of loss. And the loss is behind the rotor. You can conduct this procedure both on adjustable concaves, these two, and on the separating ones. On the separating concaves, the factory set position is neutral, but you have the option to increase or decrease the angle. Concerning the other two concaves, the inclination is maximum, so is the output speed. But if it's necessary to slow down the output speed, you can change the angle. To dismount the rotor, first you have to dismount the feeder house, then unscrew the support, and dismount the rotor. First you put the wood blocks under the rotor. Here's the support, and this is the platform onto which the support bearing is screwed. This shaft prevents the rotor from falling out of the harvester and causing damage. Then we unscrew the support and take the rotor out. For this procedure, use special weightlifting mechanisms. When mounting the rotor, take into consideration the position of the concave's frame, and it's important that this part is located below. This way, it will be easier to push the rotor inside. If you leave the window in the lower part of the concave, it will be much more difficult to push the rotor back inside. In the rear part, there is a hatch that we can remove for it to be more convenient to mount the rotor. Here you can see that the crane and strap were used to hold the rotor. Then we place the clutch on the rotor reduction gear. After the reduction gear is placed on the rotor, meaning it's fully geared, remove the straps and put the hatch back on, and at the front part of the rotor, you fix it on the support platform, as shown in this picture. So you screw on the support plate, use the jack to lift the rotor, and fix the support bearing. When mounting the support bearing, don't forget, it has two greasing points, one for the bearing shell and one for the bearing itself, and there is also a clamper. The clamper must be located below in such a way that the support points are above. Otherwise, when you open the window, and if you forget about the greasing points, you turn it, lock it, and then you find out that the greasing points are somewhere below. This will make it almost impossible to maintain the rotor support. To dismount the concave frame, first, dismount the feeder house, then dismount the rotor. Then the input cone, which prevents the concave from being dismantled, because it's fixed with bolts on the circumference. And only after that, we can dismantle the concave frame. You dismantle the whole frame. In case of severe damage, you can cut it with angle grinder on the spot of the damage, and then dismantle it. The new frame must be mounted through the front part. Also, before dismounting, remove the shafts from the frame, because they won't allow the frame to go through the hole. Straw beater. The straw beater is located behind the rotor, and is used to speed up the straw output behind the rotor. This is what it looks like. Here's the straw coming out, and here there is a concave. The beater moves against it, catches the straw, and speeds it up on the output. And this is what the straw beater looks like. It has replaceable pads, similar to the ones on the feeder house. As they wear out, you can turn them by 180 degrees. If both sides are worn, you have to replace them. A stationary concave has got 4 rows of holes. This is what it looks like on the old machines. On the newer models of harvesters, there are only 3 rows of holes. 3 rows of holes are left for the lesser probability of clogging the beater with straw. Straw beater drive consists of a belt drive which goes from the main counter drive. Additionally, on the pulley, a safety clutch is installed, adjusted for 60 kg force per meter. It is adjustable and has to be maintained annually. The straw concave clearance adjustment. This section has got only one adjustment point. It is used to set the clearance between the concave and the beater. These rods on the left and on the right must have similar adjustment. To measure the adjustment, we have a scale. The scale shows the clearance between the concave and the beater. Also, you can visually check it through the window. The clearance adjustment depends on the mass. In case you work with a lot of mass that contains a lot of straw, you'll have to increase the clearance to prevent beater clogging and stopping. A frequent mistake every time there is clogging. One might think that the only reason of clogging is small clearance, but this is wrong. It works in a different way on the beater. When there is too much straw and the clearance is too big, the falling straw gets stuck on the concave and starts clogging it. In this situation, the beater cannot move anymore, and so it stops. In such cases, it's better to decrease the clearance for the straw to go through without clogging the beater. The average clearance is 25 to 30 millimeters. The cleaning system of the harvester. It consists of a shaker pan, a return pan, a pre-sieve, upper sieve, lower sieve, a cleaning fan, a shaker pan. At the end of the shaker pan, there is a finger rake. It is used to fluff the mass before it moves onto the pre-sieve. The shaker pan performs reciprocal movement, and when the grain is transported, the grain is sieved down, and the lighter particles such as straw and chaff are kept above. And when moving to the pre-sieve, the finger rake holds the chaff and straw so that the grain is spilled first. At the same moment, there is airflow from the fan in this part. The construction of the upper sieve also includes the pre-sieve, or as it's called, an additional sieve, and the upper sieve itself, which is divided into 2 adjustments, the upper sieve extension and the main part. The pre-sieve has got 2 adjustments. Here you see 4 chaffer fins of one color and the other chaffer fins of another color. The first part is adjusted with this lever. It is located on the inner side of the combine. On the left side, there is a small hatch. To change the clearance of this section, open the hatch, put your hand inside, and using the lever, perform the adjustment procedure. The other chaffer fins are adjusted with a special tool, which you can find near the left back wheel of the harvester. Use this wrench to rotate the axis. This way, the sieve's clearance will change. To control the clearance, use the scale on the other side of the bridge. There are 2 scales for two parts of the sieve. This pre-sieve is adjusted to the size of a clean grain. If the clearance gets too big, the residuals will go directly onto the upper sieve, which will be overloaded. At the end of the pre-sieve there is a finger rake. As in the shaker pan, it is used for fluffing the mass when it's transported from the pre-sieve onto the upper sieve. In this section, there is airflow. And when the finger rake holds the chaff and straw, the fan blows it all out of the combine. Then the mass is transported onto the upper sieve. While being transported, it is simultaneously spilled onto the lower sieve. And then it moves to the extension of the upper sieve. If in this spot there are still some unthreshed parts, they must not fall through on the upper sieve. They must be transported to the end where the clearance is bigger. So unthreshed wheat heads will fall through in this part. Then they are moved for rethreshing. The sieve's clearances are adjusted from the cab. That's one of the ways you can do it. You can use the buttons on the control panel. The clearance adjustment buttons can be also found on the display. Here on the left side, there is also a switch for controlling the sieve's clearances. They're used in case the electrical part malfunctions. In this situation, if you badly need to adjust the sieves, use this wrench. With the help of this wrench, you will be able to adjust the clearance of the upper sieve, the extension of the upper sieve, and the lower sieve. Before starting the emergency adjustment, detach the electrical mechanisms from the adjustment rods. Under the harvester, you can see two electric motors for the upper sieve and the extension, and the third motor is for changing the clearance of the lower sieve. If you don't detach the electric motors, it might lead to the breakdown of the mechanisms. Ultra bushings, which are installed on the levers, are press-fitted or removed with a special dismounting mechanism. Bushings replacement must be done with special care. If you have to replace the bushings, remove the old ones, insert the new ones, but before pressing the covers, put the lever in the neutral position. And only after that, you can press the covers. This way we will extend the operation time of the ultra bushings. If the lever is set not in the end position, the wear of the bushings will not be proportional. On the one side, the bushing will have a big operational range, while a lot of pressure will be put on the other side. In such working conditions, the ultra bushing wears out very fast. To put the tiller in the neutral position, you have to install the pin that will go through the tiller and then goes through one of the holes. On this platform we have got two holes. One hole is visible, while the other one is not because it is located behind the tiller. Insert the pin into the hole which is not visible. In any case, we won't be able to push the lever to this hole. That's why we can only align it with one of the holes, the one which is closer to the cab. Why are there two of them? These parts are uniformed. So on the other side, there is an identical one with another hole. Insert some kind of a pin here, and then you can press the covers. The cleaning fan has got two sections. The separator is located in the middle, so the air intake is performed in the middle and on the sides. It is driven by the hydro motor. This picture shows the air intake process. The only adjustment that the cleaning fan has is the adjustment of its RPM. transportation units, and the grain tank. The auger's unit is located behind the fan, along the movement of the harvester. It consists of a grain auger and tailings auger. The tailings auger comes after the grain auger. The grain goes down the chute board and falls here. This clean grain is spilled through the lower sieve. Unthreshed wheat heads also fall here, down the chute board, through the extension. The elevator moves the clean grain into the grain tank. Unthreshed wheat heads are transported to the rethreshing unit. The grain elevator and tailings elevator are located on the right side of the harvester. It has a transporter tension adjustment. To detect if you need to adjust the tension, open this hatch, grab the blade and try to incline it up or down. The acceptable inclination angle is 30 degrees. If we open the hatch and see that the blade is hanging down, it indicates that the transporter needs tension adjustment. If you can't move the blade up or down at all, it shows that the transporter is too tight and you have to loosen it. If the transporter is too loose, the rubber blades will be worn much quicker. To adjust the tension, you have this rod and the nut. The grain elevator also has got a safety clutch. Through this pulley, the grain elevator and auger unit are driven. Here is the shaft, and here you see the chain drive. For the elevator, auger, and the loading auger. The trigger instant is 180 newtons per meter. This clutch is non-adjustable, which means you can only check it. If the trigger instant is not nominal, most probably this clutch must be replaced. Tailings elevator. The tension is also checked by inclining the blade. There is also a rod for adjusting the tension. Before rotating the rod to adjust the tension, you have to loosen the tension roller in this chain. Because if we start pulling the elevator and tensioning the chain, this part goes higher, the chain is pulled, and the tensor starts pressing the chain more. So the tension of this chain is too high. First loosen the roller, adjust the elevator tension, and then adjust the tension of the given chain. And here is the rethreshing unit. The tailings elevator is driven on the left side. The belt drive goes from the main counter drive. On this pulley, there is a safety clutch with a trigger instant of 180 newtons per meter. This shaft is also an auger that returns the rethreshed grain to the cleaning unit. The rethreshing unit has got 3 rotors, which thresh the unthreshed wheat heads against the concave. The concave can be easily dismounted to inspect for damages. You can also inspect the mechanism itself or the rethreshing part. To do this, take out the stopper, unlock the clipper, and dismount the concave. In case you have to replace the rotor, to take out the finger and dismount the blade, you have to push out the bearing, and then you will see the slit for taking out the fixing pin. After that, we can take out the pin and replace the blade. the grain tank of 10.5 cubic meters. Torum 780 has got a grain tank of 12 cubic meters. Each Torum harvester has got a vibration agitator function. When the back wall of the grain tank vibrates, it shakes off the wet grain from the back walls of the grain tank. This function is activated from the cab on the control panel. As long as you hold the button, the function is activated. You can't use this function unless the grain tank is 1/3 full. In case the grain tank is more than 1/3 full, the cylinder can break down, and so can the place where it's fixed on the rear shaker board. To access the grain tank when the roof is closed, you can press the clampers and the shutters will open. Behind them, there is a ladder to access the grain tank. The 12 cubic meters version has got a hatch. To unblock it, you have to loosen the bolts. Turn the locks, all the 6 of them. When you open the hatch, you will also see the ladder to access the grain tank. The loading auger of the grain tank has got a hatch. This hatch is used for repairs and maintenance. This auger is driven with the angle reduction gear. At the end of the loading auger, there is a deflector. Using this deflector, you can control the proportional spreading of the grain in the grain tank. Inside the grain tank, there are 2 horizontal augers for unloading. On each auger, these black shields can be adjusted. At this moment, they are completely lowered. This way, you adjust the unloading speed. The wider you open the shields, the faster is the unloading speed. If the grain humidity is more than 20%, then the shields must be lowered to the maximum, as shown in the picture. The unloading drive is located on the left side. The unloading drive is autonomous. It's not dependent on thrashing and separation unit. To activate the unloading, you simply need to have a running engine. After unloading is activated, this hydro cylinder pulls the belt. The belt starts rotating the pulley. On the other side of the shaft, opposite the pulley, there is a sprocket and a long chain drive for rotating 2 augers in the grain tank and the reduction gear of the vertical auger. Here's the angle reduction gear that delivers the rotation from the vertical part to the horizontal one. This is what the auger drive looks like. This is the first auger and this is the second one. Delivery to the vertical one. And here's the drive to the vertical one. And unloading onto the truck. Everything is similar in the 12 cubic meters machines, but the auger has got more flights. There's an unloading safety device. In case the augers are overloaded, for example when the auger shields are open, or in case of high humidity, the augers can be overloaded. To protect the mechanism, the drive, or the augers, there is a safety device in the form of a shear bolt. It is located on the shaft. There are 2 discs which are connected with the shear bolt. In case of overload, the shear bolt is cut. One of the discs still rotates. The belt rotates the pulley. The other disc, which is geared with a sprocket, does not move. Unloading is not driven. There are 5 spare shear bolts and 1 installed between the discs. The angle reduction gear by Bondioli transfers rotation from the vertical part to the horizontal one. straw chopper and spreader. It is located at the back of the harvester. Its main function is chopping and spreading the straw across the field. The straw and chaff from the cleaning are transferred to the chopping drum. There, all of this mass is chopped and spread across the field at the length of the header. The chopper has got two work modes: chopping on the left and windrower on the right. So if you don't need to chop the straw, using the electric mechanism and the buttons, you can switch on the windrower mode. Thus letting the mass spread freely across the field. It is shown in the picture below. To change the operation mode between the chopper and the windrower, use the given control panel, which is located at the top at your arm's length. Before pressing the buttons to change the mode, you have to unblock the clippers on both sides of the harvester and take out the fingers on both sides. After you have taken out the fingers and unblocked the clippers, you operate the buttons, and with the help of the electric mechanism, the chopper is folded. This picture shows the complete folding of the chopper. When the chopper is folded, the belt becomes loose. It means that the chopper won't start. When the chopper is transferred to the windrower mode, you have to insert the fingers. And most importantly, press the button that transfers to the chopping mode. It is necessary to put the whole chopping unit onto these fingers. This way you take all the load off the mechanism and transfer it onto the fingers. If the unit switches on by itself, for some reason, in the windrower mode, when chopping and spreading system is in this condition, but you see that the drum is rolling, this is abnormal. If this happens, you have to adjust the position of the loose belt. The belt might not be loose enough. First you check it on this pulley. You have to check the distance between the pulley and the shell ring, and also check the length of the tensor spring. To adjust the spreading width, use the wing nuts. Loosen them and adjust the two sides separately. Torum 780 has got two electric drives. With the help of these drives, you can adjust the spreading width. Left and right sides separately. You control the spreading width on the display in the cab. Also, these rods help us to adjust the spreading distance. By changing the length of the rods, you either lift or lower this part. The higher you lift it, the bigger is the spreading distance. If you lower it, the spreading distance gets shorter. In the upper section of these rods, there are holes. You lift or lower the rods using these holes. There is also a cutting length adjustment. Based on the conditions, you decide which cutting length is necessary. To change the cutting length, you move the shear bar and its other components. You move the shear bar deeper into the chopping zone or away from it. The more we move it towards the chopping knives, the shorter you make the cutting length. The further you move it away, the longer is the cutting length. Also, we have a chopper shield which is attached below. You might need it for the following operations. If the chopping length adjustment is not enough, and when the chopping adjustment is set to the shortest length, and you have to make the chopping length even shorter, you unscrew this shield, and is installed on the inside. When this shield is installed, the mass will be hindered, and the knives will be hitting it significantly more times than usual. Thus, the cutting length will be even shorter. Please remember that when you install this shield, the chopper drive is more loaded and the fuel consumption increases. Regularly check the condition of the knives. They must not be broken or damaged. Different types of foreign matter may occur and damage the knives if the knife is deformed or if some part of it is missing. Disbalanced beating may occur. The more damaged knives you have, the more the beating is. This may lead to damage in the body of the chopper. You have an option to install stronger knives. They've got a different number, and they can be bought separately as an option. In the basic configuration, there are standard knives. When you see the damaged knife, you have to replace it together with the opposite one. For example, if this knife is damaged, even though the opposite knife is in perfect condition, you must replace it as well. The new knives will be from a different weight group, so by changing them both, we will maintain the balance. Also, none of the knives must be jammed. All of them must be moving freely. Narrowing devices is a new option. They are made in the form of grills. If you look at the harvester from the top, imagine we have a chopper here. The narrowing devices are put this way. They're used only for the windrower mode, and they narrow the outcoming mass. Combinary equipment for harvesting rice. First, you install the deflectors on the header. For this, you have to drill in the lower part of the header, so that we could fix the deflectors through these holes. To re-equip the thrasher, you dismount the concave and plug the holes. To do this, you use special bolts in the places where the concave is fixed. Also, you have to lower the RPM. To do this, take off the drive belt, fix the tension roller for it not to be loose. From the spare kit, install the sprocket on the shaft and then the chain. Replace the short chain that has been previously installed with the long one. The concaves are replaced with the ones which are used for harvesting rice. They have oval holes but no rasps. For the reinforced frame, the concaves are also reinforced, which is the feature of all the modern combines. The rotor also must be re-equipped. For this, dismount the rasps. Remove these loose bolts. Instead of the bolts, and in the places for rasps, you install such type of plates. There are 4 types of such plates. 2 pieces of each type. The plates must be installed in identical pairs. In the end, these plates create a kind of a spiral around the rotor. After you install the plates, these holes must be plugged. From the kit, you install the agitator. Its adjustment comprises 3 holes. The furthest one is for moving the agitator out of the thrashing zone. Using the next hole, you insert it by 15 mm and the last one by 30 mm. These agitators make rice thrashing easier. Additional segments from the kit are installed on the intake beater of the feeder house. A special drain pan is installed to protect the cleaning fan cover and the auger unit from damage, because harvesting rice is normally done in difficult conditions on humid soil. Combine re-equipment for harvesting corn. The rethreshing unit is modified in the same way as before. You dismount the concave and plug the holes. You dismount the drive belt and put the chain drive, here are the chain and a sprocket, for lowering the RPM. Then you install the concaves with oval holes and rasps. Earlier, a shield was attached to the sieves. It was done to protect the fins from being damaged by cobs and other foreign objects. These days, all the modern harvesters have got a protective plate. Here's an example of a previously installed shields. When you re-equip the feeder house, the mass deflector is removed and the stone trap is closed. This is done to prevent the stone trap from filling with cobs and corn. And this way you close the cover. Instead of the intake finger beater, install a shaft with rubber blades. The chopper spreader speed is decreased. To do this, loosen the tensor, take out the finger, turn it around by 180 degrees, put the bigger diameter in the place of the smaller one. Then put on the belt, but on the other pulley. For it, there is a special hole. This will enable to lower the RPM in such type of re-equipment. After lowering the RPM, you have to save the new nominal RPM of all the frequencies. In the re-equipment kit, there is an apron assembly. The apron protects the lost sensors from failing. It is installed from the inside, under these bolts on the edge. This is what the apron looks like. It also protects the fins of the sieves from being damaged by corn and other foreign matter. For harvesting corn, you also dismount the knives. Re-equipment for harvesting hard threshing crops. Non-reinforced concaves were equipped with shields. You have to close the first section with shields. In this case, here the mass will be separated, and here it will be ground. It is done to remove the protective layer on the hard threshing crops. If we speak about reinforced concaves, here you see that the shield is separated into 6 sections.